are the operational backbone of modern attacks. After initial access, the attacker deploys a beacon, a lightweight implant that phones home to a team server on a regular sleep interval. Every check-in, every task, every exfiltration happens through this channel. The beacon lives entirely in memory, uses legitimate processes as cover, and leaves no files on disk. Memory forensics is how you find it. The C2 architecture has three components. The implant, called a beacon or agent, runs inside the victim host. The team server receives check-ins, queues tasks, and sends commands. The operator interacts with the team server through a client interface. The implant is the only component visible in memory forensics. Its config block, communication stack, pipe names, and sleep pattern are all recoverable from the process memory where it injected. Cobalt Strike is the most widely abused C2 framework in active campaigns. Its beacon is a reflectively loaded DLL injected into a host process. The beacon config block is stored as an XOR-Encoded structure inside the beacon's memory region, containing the team server address, sleep interval, jitter percentage, user agent, named pipe name, and post-exploitation behavior settings. Volatility and cape extract these configs automatically. The Cobalt Strike beacon config is a fixed-length structure embedded in the beacon's memory, typically XORed with 0x69 or 0x2e. It begins with a watermark, followed by type length value encoded settings. Key fields include server and port, sleep time in milliseconds, jitter percentage, user agent string, named pipe template, spawn to process for fork and run injection, and license ID. The license ID alone can attribute a beacon to a specific threat actor. Meterpreter is Metasploit's primary post-exploitation agent. It exists entirely in memory, communicates over TLS with the team server, and loads extension DLLs on demand via reflective injection. A staged Meterpreter uses a small stager shellcode to download the full stage from the team server. A stageless Meterpreter contains the full payload from the start. Both appear in memory as anonymous executable regions detectable with malfind. Sleep obfuscation is a modern evasion technique used by advanced beacons. During the sleep interval between check-ins, the beacon encrypts its own code and stack in memory, making it invisible to signature-based memory scanners. Techniques include Ekko, which uses Windows event timers, Foliage, which leverages fibers, and Gargoyle, which uses ROP gadgets. In memory forensics, sleep obfuscated beacons appear as encrypted blobs during dormancy but decrypt before each check-in. Named pipe and SMB beacons enable lateral movement through network shares. Instead of connecting directly to the team server over HTTPS, a compromised internal host routes its traffic through a pivot host that has external connectivity. The internal beacon communicates via named pipe to the pivot, which relays traffic to the team server. In memory, named pipe beacons show no external network connections but have open pipe handles with characteristic beacon pipe naming patterns. HTTPS beacons disguise C2 traffic as legitimate web traffic. The beacon contacts the team server over port 443 with a malleable C2 profile that customizes headers, URIs, and encoding to mimic known legitimate services. JA3 fingerprinting of the TLS handshake can identify Cobalt Strike regardless of the malleable profile because the cipher suite order remains constant. In memory forensics, netscan shows the connection to the team server IP and the owning process. DNS beacons encode commands and exfiltrated data in DNS queries and responses. Each check-in is a DNS query whose subdomain contains base 64 encoded data. The C2 server responds with encoded commands in the text or a record. DNS beacons are extremely stealthy, they generate no TCP connections, use legitimate DNS infrastructure, and bypass many network monitoring tools. In memory, the beacon's config reveals the DNS staging domain and encoding key. Fork and run is the default post-exploitation pattern in Cobalt Strike. When the operator runs a post-ex command, the beacon spawns a sacrificial process using the spawn-to setting, injects a post-exploitation DLL into it reflectively, executes the task, captures output over a named pipe, and kills the sacrificial process. This keeps the main beacon process clean. In memory, the sacrificial process appears briefly as a reflective injection target. YARA rules for C2 detection target the beacon config block structure, characteristic strings in the beacon DLL, and common API hash values used in hash-based import resolution. The Cobalt Strike beacon YARA rule matches the XOR-Encoded config header pattern. Meterpreter rules match the metsrev.dll string and the TLV communication protocol header. Running these rules with volatility YARA scan across all process memory finds beacons regardless of the host process they injected into. Beacon detection via netscan cross-references network connections with process memory. The beacon creates a TCP connection to the team server on port 80 or 443. Netscan shows this connection with the owning PID. Cross-referencing that PID with malfind ordlist reveals the injected beacon. Comparing the connection timing with sleep intervals confirms beaconing behavior. A connection to a fresh domain with low TTL registered recently is a strong indicator of a team server. Hunting beacon configs in memory requires scanning process memory for the XOR-Encoded config pattern. The Cobalt Strike config starts with a 2-byte header followed by the watermark value. After XOR decoding with the known key, the type length value fields reveal full operational parameters. Tools like Beacon Hunter and cs-decrypt automate this extraction. The recovered config gives you the team server, sleep time, jitter, pipe name, and the license key that may identify the threat actor. The detection matrix for C2 frameworks. Cobalt Strike beacon appears as reflective DLL in malfind with XOR config block. Meterpreter appears as anonymous executable region with TLV protocol strings. DNS beacon has no TCP connections but characteristic DNS query patterns. Named pipe beacon has open pipe handles with beacon naming format. Sleep obfuscated beacon appears as encrypted blob that decrypts on check-in. All are found in memory without disk artifacts. Your Vol.8 command toolkit, malfind finds the injected beacon. YARA scan with Cobalt Strike rules extracts config. Netscan correlates connections to beacon PID. List shows the host process module list for anomalies. WADump extracts the beacon memory for offline config parsing. Vol.9 covers rootkits, DKOM, SSDT hooks, DKOM callback removal, and kernel-level hiding techniques that make all other forensics harder.